Imagine stepping into a world where plants are not just passive greenery but fierce defenders equipped with their own arsenal of weaponry. Take the prickly cactus, whose spines deter thirsty predators, or the hemlock, whose toxins are potent enough to stop a predator in its tracks. But some plants don't stop there. They go on the offensive. The parasitic dodder vine, for instance, seeks out its host by detecting chemical signals, then latches on to siphon nutrients. It's like a botanical vampire. Over millions of years, natural selection has shaped plants into master strategists. Some even use chemical warfare, releasing airborne signals like jasmonic acid to warn neighbouring plants of impending attacks or to attract predators of their herbivores, such as wasps that prey on caterpillars. And what about mechanical traps? The Venus flytrap uses a trigger mechanism to snap shut, turning predators into prey. The Mimosa pudica, or sensitive plant, rapidly folds its leaves when touched, startling herbivores. The acacia tree forms a mutualistic relationship with ants, providing them with food and shelter, in exchange for protection against herbivores. These plants may not walk or talk, but they've got defense mechanisms that would put any zombie movie to shame. But plants aren't the only ones with tricks up their sleeves. Enter the real-life zombies, parasitic fungi. Take Cordyceps fungi, for example. They infect insects, hijacking their nervous systems and forcing them to climb to high places. Once there, the fungi burst through their host's body, releasing spores to infect others. It's the ultimate zombie takeover. These fungi don't stop at ants. Some even target caterpillars, beetles and spiders. The science behind this is mind-boggling. These fungi release chemicals that manipulate their host's behavior, turning them into unwitting accomplices in their own demise. One of the most fascinating examples is Cordyceps unilateralis, which specifically targets ant colonies. This fungus compels infected ants to leave their colonies and climb vegetation, where they latch on and await their fate. The chemical processes involved are intricate. The fungi release a cocktail of chemicals that override the ant's central nervous system. These chemicals manipulate the ant's brain, forcing it to act in ways that benefit the fungus. Eventually, the fungus grows out of the ant's body, releasing spores to infect more ants, perpetuating the cycle. This complex interaction between fungi and their hosts showcases the incredible adaptability and cunning of nature's real-life zombies. While Cordyceps wields its zombifying powers, plants and herbivores are locked in an eternal arms race. Herbivores have evolved specialized adaptations to counteract plant defenses. Take the monarch butterfly caterpillar. It feeds on toxic milkweed, storing the poison in its body to ward off predators. But plants don't back down. Milkweed, for example, produces sticky latex that gums up the caterpillar's mouthparts. This back-and-forth battle drives innovation in nature. It's evolution in action, creating some of the most fascinating adaptations on Earth. Consider the passion flower and the heliconius butterfly. The passion flower has evolved to produce structures that mimic butterfly eggs, tricking the butterfly into avoiding laying its eggs there to prevent competition. In response, the heliconius butterfly has developed the ability to detoxify the plant's chemical defenses. These evolutionary mechanisms showcase the intricate dance of adaptation and counter-adaptation. This relentless struggle for survival fuels the diversity and complexity of life on our planet. But this delicate balance is under threat. Human activities like deforestation and climate change are tipping the scales. Take climate change. It's altering habitats, forcing plants and herbivores into new environments where they struggle to adapt. For instance, in the Arctic, warming temperatures are causing the tundra to shrink, pushing herbivores like caribou to find new grazing grounds. Some species unable to keep up face extinction, while others, like invasive plants, thrive and upset ecosystems. In Australia, invasive species like the prickly pear cactus have overrun native landscapes, making it difficult for local herbivores to find food. Without intervention, we risk losing the intricate web of interactions that sustain life on Earth. In the Amazon, deforestation is not only reducing plant diversity, but also disrupting the food chain for countless herbivores. But there's hope. Through conservation and sustainable practices, we can protect this battle royale of nature for future generations. Efforts like the Great Green Wall in Africa aim to combat desertification and restore habitats for both plants and herbivores. Nature's plants versus zombies battle is happening all around us, in gardens, forests, and even cracks in city sidewalks. Take a closer look at the plants and fungi in your backyard. Share your observations, support conservation efforts, and help preserve this fascinating world. Who knows? The next great discovery might start with your own backyard exploration. Join citizen science projects like eNaturalist or Project Noah to document local biodiversity. Participate in community workshops and events focused on planting native species and restoring habitats. Volunteer for clean-up efforts to remove invasive species and protect native plants. Advocate for environmental policies that support conservation in your local government. Educate others about the importance of biodiversity and inspire them to take action. Throughout history, the interactions between plants and fungi have fascinated human cultures. These relationships have shaped ecosystems and influenced our lives profoundly. In ancient Egypt, the sacred lotus flower symbolized creation and rebirth, thriving in the nutrient-rich waters of the Nile. Across the world, Theophrastus documented plant-fungi partnerships in ancient Greece. These observations laid the groundwork for early botanical science. Folklore and mythology are rich with stories of plant and fungi interactions. In Celtic legend, the oak tree was seen as a powerful protector, often depicted with magical fungi growing at its base. This connection between the natural world and the supernatural is a recurring theme. In Japan, Shinto religion venerates sacred groves where trees and fungi house spirits. These spaces underscore the spiritual significance of plant-fungi interactions. Even today, these ancient tales influence modern culture. The iconic imagery of mushrooms in fantasy worlds draws on historical roots. These stories remind us of the enduring legacy of these natural partnerships. By understanding the history and mythology of plant and fungi interactions, we can better appreciate the delicate balance of nature and our place within it. Like and subscribe for more fascinating facts.